Hello, everyone. Welcome to the last talk of the day. I won't make the usual last talk jokes, so I'll keep that from you. Um, so I'm Jona Apelbaum. I'm a solution architect at Solo.io. Uh, we'll dig a little bit deeper what Solo.io is in a second. I'm based in Madrid, but originally from Belgium. This is why I speak Dutch.
And I'm Alessandro. So today we're gonna talk about platform engineering. I don't know. You may have heard this term before, even this very same conference. So we will give you our outlook, our view on how does it mean to build a platform, how to secure these platforms, and how to make them more functional for your developers, right? So we'll take it from there.
And before we start, quick question. Who runs Kubernetes in production today? Awesome. Okay.
Cool.
Who does this multi-cloud? I was expecting that. Yeah, it's true. Multi-cloud. We speak about multi-cloud, but there is hardly really multi-cloud, is it? Right? So we'll talk a bit more about that because the fact is just that people use one or two function in another cloud, but they have like 95% of their workload in one cloud. So this is always an interesting fact to ask that question. So I hope while the years evolve, I'll see more hands. But right now, I never expect too many hands up when I ask that question. Cool. So we'll talk about platform engineering.
Yeah.
So here you are. He has a better picture than me.
So a shout out to two previous talks at this conference. Of course, Chris Ayers, I don't know if he's in the room or not. I know that Jessica left. So Jessica talk was about platform engineering, how to build a platform. So we were there with great talks. So I hope you catch them up like we did. Jessica said that you don't need service mesh. Maybe she's watching the recording right now. But our position is that you do need. I mean, you don't need anything, but it would be much easier if you use service mesh in your platform, right? So
I will show you why.
some agenda. So we're gonna talk about what is a developer portal, how to pimp your IDP, internal developer portal with service mesh. Talking about multi-tenant, multi-cloud, multi-clusters, multi-everything. We're gonna talk a lot about automating things because really, when you go on scale, when you want to offer a portal to your developers, you don't want to do anything manual. You want to automate everything that you can. And so we're going to talk a lot about GitOps. If you ever heard about it, we're going to do a quick intro to it.
Essentially, the idea is for developers, and you hear this a lot. Developers should focus on business logic more than they should focus on one security. I always say I don't trust developers, not because I don't trust the person. Don't understand me wrong, but I don't trust them to understand security, right? So you don't want to put that in their hands. And secondly, putting things in production involves many things: deploying infrastructure, deploying it on your Kubernetes cluster, making it available externally. There's a lot of things involved, and what we want to show is that developer platform can provide that in a completely automated way, and we'll actually demo that as well.
Yeah, somebody told me yesterday, don't trust any human. It's okay. I mean, humans do make mistakes, but also doesn't mean you should trust AI because AI is made by humans. So I think you should just verify and test everything. That's the best approach. So it's a demo AV talk. So yeah, there's gonna be a bunch of slides, but most of the time we'll try to spend it on the terminal
And show some cool stuff.
not Visual Studio Code because he use IntelliJ, but some Visual Studio, some code editor will show you some cool stuff, and then we'll wrap up and we'll see where we go.
So who's Solo? Some people say it came out of nowhere. Not true. Who's familiar with Istio? Awesome. More and more. This actually, the hand goes more and more. So that's good. People start to understand service mesh, Istio. We're not the only ones. Essentially, a lot of people at Solo came from the Istio space. With, for example, the founder, one of the founders of Istio, just joined us as a CTO, and on the Istio CNCF board, we occupied 3 of the 6 seats, right? So we didn't come just out of nowhere. Sometimes we come into company says, "Who are you?" Okay, yeah, we don't know the name of the company, but we are experts in the field, and we collaborate a lot in the open source space. We're one of the main contributors to Istio. And me and Alessandro were here to kind of spread the word on Istio and the company, of course.
Yeah.
Right?
If you don't know what service mesh is, we'll have a quick intro. Our position is that every cluster deserves a service mesh. So it doesn't matter which one. We think Istio is one of the best, but yeah, definitely you should look into what service mesh can do for you, and we'll talk about it. So what is a developer portal? You may wonder. So yes, so IDPs, which stands for internal developer portals, which is, it says internal because it's most likely aimed at your own developers, as opposed to external developer portal if you ever have this kind of needs of offering an interface to your infrastructure to developers that are not part of your organization. But in general, like IDPs mean this interfaces, this layer of abstraction over your services, your documentation, over everything that you offer on the back end, put on an abstraction layer and offer as a coherent and consistent offering, a portal, as it says, to your developers, right? So it's really, I think it's pretty cool idea, this raising up in the last few years. So we don't just build things for the sake of it. We want to offer them to developers. So because the ultimate goal is to increase developer productivity. So I have this. We put back the developers in the center and in the spotlight.
So a lot of people know developer portal as something like to expose APIs, from developers to consume APIs, etc. An internal developer portal is pretty much the same concept, but exposes the what do they need to do to expose this application externally as a platform, right? So it kind of is the inside version of what the external developer portal provides on how to deliver these applications in an automated way, essentially.
Yeah, yeah. So and why they're popular now? So there is a bunch of projects within the Cloud Native Complete Foundation, as I'm part of the CNCF. So there's a bunch of projects that are now being part of, including the CNCF, like Backstage and other ones. So there's a movement that is bringing the developer back into the center and as the center of productivity. So some properties or some wishful properties
some advantages
of a internal developer portal are they are self-service, so developers should not be going through some form of bureaucratic approval to use the services that they need to. So they are comprehensive, so they should at least cover the majority of your services of the company that you are working for or the service you want to offer. Should include the best practices, as in they should embed what's the best ways to use those services. So like we're full of examples and documentation. So documentation is actually one of the reasons most companies, organizations approach an internal developer portal, to have a central place where every developer can just pick up a service and read everything that is there about the service. And it's also, this also of course like increased productivity, because you don't need to, or the information is not scattered around dozens of systems.
I'll say even more, it's having multiple teams collaborate. So the platform team, security team, the networking team all collaborate on a central platform to establish a single truth. So at least when I deploy an application, I know I'm going to obey to that truth, right? And I can just do it. It's pre-approved almost, right? So the old ITIL-based way of working, where I deploy an app, I need to wait for somebody to open a firewall port, I need to wait for somebody to do something, should just be, the portal is there to automate that piece, because somebody has already done the job for you in forehand, right? Yeah. So that's the idea of a developer portal, to kind of go from, I used to call it the continuous deployment, continuous disappointment, right? Because at least once you get to the deployment phase, you have to wait for somebody to do something, and you need to avoid that as much as possible.
Yeah, so frictionless, seamless developer productivity should be what you aim for.
I'm gonna.
Most likely, those porters are built by a dedicated team, the mythical platform engineering team. There's a bunch of people now transitioning from the classical DevOps role into this platform engineering team. It's simply a team task with building these porters, building this experience for developers. Our take is that if you are building these kind of things, you gotta think about security early in the process, so shifting left security, so nothing built on top, so security bolt on the platform after you build it, but you have to think about it in the beginning, and that's why some part of our talk deals with that. And you have to automate everything, so the discovery of services, the deployment of those services, the upgrades, they should be all automated. So for all this, you do need some tools, right? So we love tools, and we talk about some of these today.
Oh, I see. Yeah.
So of course, Kubernetes, we love it, we hate it, somebody hate it, I personally love it. I'm biased because I run the Dutch Kubernetes meetup, so I've been doing Kubernetes for a long time, and I still love it. So there's no 7 years, I've been doing it for 7 years, and there's no 7 years crisis in Kubernetes. So far, so good. Don't tell my wife. Argo CD, if you know it, if you don't know it, I think you're gonna love it if you try it, because it's one of the tools that is being very popular now and enables GitOps. So, and what is GitOps? We're gonna talk about it, but Argo CD is one of the 900.
Who knows Argo CD here? Okay,
see?
cool. Who doesn't know Argo CD?
Okay. Istio, right? So our position, you can say, because we are biased, of course. We've been in the Istio community for some time. We love service mesh, and we think that a service mesh enhances the experience for developers, because introduce concepts like security, manageability, ease of operation, things like ease of monitoring of services, because you're using a service mesh, and in particular Istio. So it's just one extra thing, indeed. So introduce some complexity, but solves a bunch of problems that otherwise you have to solve yourself. So Istio is one part of the platform that we really want you to understand, and this talk is about that. And security, of course, one of the top tool on the market is HashiCorp Vault. It's a great tool. It does automated secret generation.
So who knows Vault? Cool. So so Vault does a few things, right? For who doesn't know, because I came from HashiCorp, so I know Vault quite well. But Vault does a few things. The most famous thing that people use it for is secret management, dynamic secret management. So how do I make sure that nobody needs to keep secrets, but I generate secrets on the fly and make them valid as little as possible, which is one of the principles of zero trust. Don't ever have long-lasting tokens or certificates or anything, right? The certificate, which is the second thing, which I'm going to show both in the demo later, both the injection of tokens as well as certificates. Vault is also a PKI, right? Or can function as a PKI. So this is both things are, and then Vault can do many more things, but these are the two basic things that we use Vault here today as well.
Yeah. So these are the behind the curtain of platform, the tools that runs the show, right? So, and the developers don't need to care that much about all these tools, because we put them together, we glue them together in a very fancy way, and in the end is a service that is consumed by the developer. So we show you some ways to glue these things together, how they work together, and why we choose this particular one. And of course, like all this runs in public cloud, private cloud, whatever.
It's multi-cloud.
It's multi-cloud. So all this stuff we show is actually running on Minikube.
It might run as on kind, yeah. So it doesn't matter. But
yeah. So if it runs on kind, means that it can run anywhere you have a Kubernetes API, really. So a cluster with multiple nodes, few nodes, it doesn't really matter.
Because I run it locally, because I don't trust any internet at any event. So I try not to be dependent on it too much.
So
what?
Yeah, I left it from the template. But so some things, just a little intermezzo about SRE, Platform Devops, why we are here and where these things come together. These are developer conference. We did this in talk Tuesday on Voxer Days. There was a Java developer, now we have .NET developers, but as developers, you probably have heard of the things, of the ideas behind DevOps culture. You may or may not be exposed to this platform engineering movement, which aims to make the job of a developer easier or more frictionless. And then in the middle, we got this new thing, which is not that new. Google released the SRE book 5-6 years ago, something like that. So it's not exactly yesterday. So there's been some time that people started to absorb this idea behind SRE, site reliability engineering, and how these things combines with DevOps and platform engineering is where the magic happens. I think I'm very excited to talk about these things because it's finally, I've been doing DevOps for quite some time, and it was mostly tools and culture talk, right? So a lot of people talk about the DevOps culture, and now you can reuse those ideas into your platform engineering team. So DevOps is basically the tools that you need to run the show, right? So, and then SRE is all about keeping the lights on, and these tools that we show today is also, they are part of the tool belt of SRE. So it's all together, right? So it's we are just one. These are not silos, right? So DevOps, the meaning of DevOps was to crush and destroy the silos between people. So all these people, even if they are part of different teams, should work together, and that's why we share the same tools and the same culture.
So, service mesh. It's a subject that we all love at Solo. So what is a service mesh? I'll explain it with two different explanations. One, imagine when you type an address in or you want to go to somebody's house, you put in GPS, it's going to bring you there. You don't know where you're going, but it's going to bring you there to some way, right? It's the same with services. Or the other analogy that I like to use, which is I call somebody on the phone, I don't know where that person is. It may be here next to me, it may be in Australia, maybe in the US. Technically, I don't care. My phone doesn't care. It just connects me to it. Service mesh is a similar principle. A service wants to call a database, for example. An app wants to call a database. I have no clue where that database sits. I don't even know what proper address I need to use in my connection string. Frankly, I shouldn't be caring about it, right? I just want to call my database. This is what service mesh does for you. It keeps track of where services are and just connects you to it. And what it does also in a secure way. So when my application connects to my database, in this particular example, I will also encrypt that connection using a mutual TLS. How do we do it? I'll go slightly deeper technical for a second. Every service, when it gets bootstrapped, we inject a sidecar. We have a sidecar-less model as well, but I won't go into that for now. Inject a sidecar. What is a sidecar? There is an extra container that gets created next to your application, and this is called a sidecar model. We're going to force all traffic through that sidecar. So we can now use that sidecar to make decisions on your traffic, right? And so one of the things that sidecar does, we will also inject a certificate that will provide an identity to that service. So when that service calls a database will say, are you actually service A? And service A will say, yeah, but am I actually talking to database? So we will do what we call a mutual TLS connection, okay? You say, okay, this is fine within a cluster, but where the real power of service mesh, what the hell, somebody's calling me now. You see, they don't know I'm here. This is service mesh, right? So I don't know who's calling me. I put myself on do not disturb. But when you go multi-cloud, right? This is where the real service mesh starts. The way I like to explain it is, with service mesh, you actually create a flat network concept across cloud, across environments, because it doesn't matter anymore where services run. We invented IPs years ago, but IP was never meant for what we use today, right? It was meant to connect some universities together. but not connect millions of devices together, right? So service mesh is here to solve it. And this is not my day today with all the, so one of the other advantages with service mesh, because we sit in the data path of our applications, right? We can also capture traffic. We can also observe that network. So the extra advantage you get out of the service mesh is now you out of the box, you get observability on your layer 4 to layer 7 traffic in between application. And that what we do with these metrics coming out of this application, we can send them to an OpenTelemetry collector, for example, if anybody's familiar with OpenTelemetry, or send it to Datadog, or send it to Elastic, or whatever, right? So, and the cool thing is, you haven't done anything. It's just there, because thanks to the fact we inject and we know all the traffic, we can also observe that traffic. So I think that's a huge advantage. And as I said, because we sit in that data path, we can control the network, which is also a part of the demo that I'm going to give in a second, is how do I deploy a new version of an application, right? I'm going to show you a build process. I'm going to change some code. I'm going to sit back. We're going to continue the talk. And then once it's built and deployed, I'm automatically going to deploy a canary version of that application, and 50% of the traffic is going to be balanced in between two applications. Why? Because I'm telling my front end, or I'm telling the ingress to send 50% of the traffic to both versions with simple service mesh objects, which I'm going to show to you.
So service mesh is built on the premise that network traffic is too important to be left to the application, right? So you need to insert something in between our proxy, so you can control and you can monitor and you can do fancy stuff.
And so multi-tenancy is another very complex thing to achieve. You can do multi-tenancy, and you should do multi-tenancy on Kubernetes level. That means somebody has a service account and can only have access to a certain namespace or set of namespaces to deploy the application. This is good. But once I deploy that application, nothing stops me unless you got network policies, but cross classes is difficult for my application to call another service, for my application to call another application. So multi-tenancy within Istio is there to solve this, to say, I work for team A, and team A should not be able to contact any application from team B unless explicitly allowed, which is another basic of zero trust, of course, right?
Just to refresh, right? So what we're talking about, a multi-tenant cluster is a cluster that is shared among multiple independent tenants. A tenant can be a team, can be a single developer, can be any entity in your organization or outside the organization. So, and then in this case, we talk about hostile multi-tenancy, where these tenants actually they are not playing nice to each other or to the administrator of the cluster. So this is one scenario. Usually, and we're talking about one single region cluster, or a cluster located in one region. Then you can have multi-region clusters, same cloud, but multiple regions. Usually, because of the architectural Kubernetes doing stretch clusters, so a cluster that stretches over multiple regions is hard and is not really recommended. So that's why we talk about independent multi-region clusters, or cluster of clusters, or a composition or a collection of clusters over multiple regions. And that's where inter-cluster communication becomes tricky, becomes something you have to take care of. Service mesh helps there. And of course, like, you can also go, instead of a different region within the same cloud, you can go all the way to a different cloud and have clusters in AWS, in Azure, talking to each other, exchanging information, making sure that your users are always served by the best cluster. There's a new, I'm part of CNCF, as I said, so there's a technical advisory group within CNCF about sustainability, and it's about also making sure that you are always using the resource or the region or the cloud that is actually at the moment the less carbon intensive. If you know what it is, it's the amount of CO2 that you are producing per unit of energy you're consuming with your resources. So it's important to have these ideas at hand, this concept, when you want to reduce your carbon footprint, because maybe one day Azure is less carbon intensive than Amazon, so you want to migrate your workloads there, but you can only do it when you solve this multi-cluster dilemma.
So multi-cluster, and I promise this is the last one before the demo, and the rest is demo pretty much. Multi-cluster Istio is a very complex thing to do, right? Not only is it complex, it's also quite unsecure, the open source Istio, unless you do something about it. So I'll show this. So what the hell? So why am I showing this? Because to do multi-cluster Istio in production, each Istio needs to have access to all the other kube APIs for service discovery. What that means that each Kubernetes cluster needs to hold the secret, the token, and the certificate of all the other clusters, right? That it wants to connect to. Which also means if one of the clusters gets compromised, you can guess what happens next, right? Okay, we talked about Vault, you can do stuff with Vault, but still, I don't like to have all my secrets into one cluster. And this is where there's one slide about our product. This I didn't want to, it's here you go. What do we do at Solo? We make this. We take that need away from having all the kube APIs talk to each other. We have an agent that we deployed in each cluster who communicates with the central control plane, which is the glue mesh, the glue portal, or it has other names. What that means also is that it's now a pull request. It's a pull method. So the agent talks to the control plane and sends its information when needed, right? The control plane will never talk to the agents directly. So now it's each cluster sends its information to the central control plane, and the other clusters take that information to consume it. So essentially, we take away that need for having all these clusters talk to each other. Now,
so the difference is that this scales geometrically with the number of connection clusters. So you have n to the to the n power of a number of clusters, and this scales linearly. So more cluster just means that you need to add one more agent.
So essentially, also it's the platform does not sit in the data path. So that means if you lose the glue platform, it doesn't matter, right? It just means you can't create new objects, or you can't create new object on the glue platform, but the data keeps on continuing. So I wanted to show you a multi-cluster quickly. I'll go to the demo, and we'll go, because I'll skip this, so up, because otherwise we don't have enough time. So essentially, here, what I'm going to show, here you go, which is it's very small? Yes, right? Here you go.
Do you want to introduce GitOps quickly? Let me introduce GitOps quickly. That's
because we don't have
we promise. So
we promised to talk about GitOps.
The demo is about Argo as well. So
let's do this.
Yeah. So what is GitOps and why we love it? Of course, it's a part of our tool in our tool belt. Argo CD and GitOps is central. So GitOps is by definition, and there is, by the way, there are two groups within CNCF: the GitOps working group, GitOps WG, which is a bunch of people getting together, reasoning about GitOps, and then producing a standard, a bunch of white papers, blog posts, and definitions of what is GitOps, and it's called Open GitOps. It's part of the CNCF. It's under the Cloud Native Computing Foundation umbrella. So it, by definition, is operation by pull request, which doesn't mean much. But what it means is that, first of all, you have a single source of truth, which is your version control system, most likely Git. So that contains the truth. Whatever you want your infrastructure doesn't, and it's not only Kubernetes cluster, can be anything really. Can be your Azure infrastructure, AWS, your on-premise network configuration, doesn't really matter. As long as you have a GitOps agent, in our case is Argo CD running Kubernetes, that applies that configuration, compares that configuration with the desired state, the actual state with the desired state, computes the differences, and applies those differences to the actual state.
Which also means that if somebody makes a manual change, you can get warned very quickly that something changed, and it can automatically remediate that change to make sure it doesn't break anything, because the single source of truth should be your GitHub repo or your source control, right?
Yeah. So what we're gonna show in the demo is that we don't touch the cluster. We really don't. We really don't even look at the cluster. We're going to look at it because we want to show you, but it's not, we could have only a read-only access to the cluster and it will work just the same. And another idea behind this, the GitOps thing, is what really people, I think why increase security, is that you have this separation between CI, continuous integration, which is meant to integrate your changes in the code into the artifact. So that's the left side of the graph, where you build stuff, where you push new code, and that new artifacts, in this case, in our case, is a new Docker image, is built by a pipeline. But then everything that happens on the right side, on the deployment side, is completely automated and doesn't need to communicate with the left side. So there's a kind of a firewall in between, which means your VCS, your GitHub Actions or whatever, they don't even need to have credentials to your clusters, because the clusters read the GitHub source of truth and applies that. So it's more secure, it's more automated. I know why people don't like it, because you relinquish control in a way. It's like a self-driving cluster. It's like driving a Tesla and raising your hands and not touching the wheel. So it's not exactly something that we are used to, but it's definitely more secure and more efficient than going in and changing stuff, or having a pipeline applying forcefully in an imperative way some state.
Because you can have people check, you do a commit, somebody does a pull request, somebody checks it, happy days, and then you can apply it to your cluster, so you have more control over what's happening, right?
Don't trust humans, right? So
I don't trust humans. Yeah.
So of all the tools, of course, it is not just one, but we love Argo CD, so it's amazing. And we didn't want to deploy Argo CD ourselves. We just wanted to use Acuity, which is a hosted control plane for Argo. It's a great company we collaborate with.
Yeah, we wanted the picture for social media to show them. We show them on our deck, right?
So what we show when we show the Argo CD control plane, the UI, we will show it, right?
Yeah, we will show it. Yeah.
So it's not running in the cluster itself, it's running somewhere else, but the cluster is connected to that Argo CD.
And the reason I use it
server.
personally is because I run it on clients. And for me to be able to do actions from externally to my client cluster, I would have to ask whoever manages the Wi-Fi here to open access to my machine. And the way that Acuity works, it deploys an agent, just like we do, that communicates with the Acuity server, with the Argo server, and does everything behind the scenes.
So no firewall,
firewall.
no punching holes.
So I'm going to show you two things. A multi-cluster canary. So I'm going to change some piece of code, right? And at the same time, we're going to explain a bit what's happening, and within minutes, it's going to be deployed a new version, and I'll have a canary release ready, right? And what is a canary? It's when you deploy a new version. You know, in the mine, there's a canary. When there is gases, it's the first one that's going to scream, there is a gas, which I think is going to faint, right? I don't remember. But anyway, it's the same concept. A canary, usually you deploy when you deploy a new version. You deploy and you say, I'm going to send, let's say, 5 or 10% of the traffic to the new version. Thanks to the fact we got metrics, you can start collecting metrics. And if you start seeing a lot of 502 or 503 or 500 errors or whatever, you see, okay, maybe something is wrong, right? So this is what a canary is for, is to be able to test things and before going to production fully. And I'll also show you a multi-cluster deployment. So the first thing is easy, the multi-cluster one. It's text-based, it's not China interface. But I want you to start with to take a look at this text here. It's backend on cluster 1. I got a front end that connects to, the front end is here, and the backend is here, okay? What I'm going to do is I'm going to deploy another version on cluster 2, right? It's 2 clusters. And the way I'm going to do this is with GitOps. I'm going to change an object that's going to say, okay, deploy that application to cluster 2, right? So here what I'm going to do is, I got, anybody familiar with customize? Yeah, anyway, it's I'll show you the object in a second. So what I'm doing is I'm telling my environment to deploy that file, that backend, onto cluster 2. I won't go into detail. Essentially, Argo is going to pick this up and going to deploy another version on cluster 2. I got Argo watching that folder, and Argo knows that whatever is deployed in that cluster 2 folder needs to be deployed to cluster 2, right? So I'm going to just push that changes, right? Add backend to cluster 2, right? I'm going to commit and push this. And to make things go faster, it's called a fake service cluster 2. I'm going to refresh this, right? And I'm going to wait for things to be synced. I'm going to sync it quicker. And we're going to see this is my backend. And within seconds, you see my cluster 2. I should maybe zoom in a little bit. But backend has been deployed to cluster 2, right? So the only thing I didn't touch my cluster. The only thing I did is change an object and tell Argo to pick it up. Now, if I go to this one, watch this little string here, I'm going to see, you see, I'm on cluster 2 now. And I'm going to balance between cluster 1 and cluster 2 all the time, right? So this is, the first thing I want to show is that multi-cluster service mesh that we spoke about. So I deployed another version of cluster 2, and I'm telling the front end, divide the traffic in between the two clusters. The way we do multi-cluster communication, front end runs on cluster 1, and back end 1 runs on cluster 1. The way the two clusters are connected to each other is with what we call an east-west gateway. So each cluster has a little gateway in between them, right? And we tell Istio to, when there is a multi-cluster traffic, route that traffic through that gateway. So Istio dynamically is going to create a route and send traffic over the gateway, and from the gateway to the end application. It creates that route dynamically behind the scenes. It's just like that GPS I talked to you about. Istio is the GPS for that application at that moment. Okay? Now, the second thing I'm going to show you, I've got a little piece of code. Sorry, it's not .NET. It's Spring Boot. So it's I know we've got a lot of .NET developers in this conference, but it's the there you go, fake service we call it. I know this one is actually Go, my bad, and the UI is Java. So I'm going to make a little change here, very, very small change. Actually, it doesn't matter what change I do. I'm going to change the color here to white. I'm just saying something. I'm not showing colors because it's easier to understand with just text in this case. And I'm going to push this change into production, right? Well, into my GitHub repo, I want to say. So behind the scene, what's going to happen, I got a action that it starts to run, and it's going to start building the code. So the action will do, it's GitHub Actions. Who is familiar with GitHub Actions? Awesome. So GitHub Actions, who doesn't know what it is, it's essentially every time I make a code change, I do a commit or a pull request, I can have GitHub Action listen to different types of activities. And I can then tell my GitHub to, okay, when you detect a change in the source code, please perform these actions. And the first action I'm performing is building my UI. The second one is I'm building the application, release the application, I'm putting that application in a Docker image and publishing it to Docker Hub in this case. And then I update my Kubernetes deployment to create my canary release. Okay? And the way, yeah?
If you switch to the presentation.
Yeah.
Yeah. No.
Yeah. Sorry.
So, and by the way, this is the...
Oh, yeah. Oh, you create a slide.
Yeah.
Perfect.
So this is what happens, right? So there is a east-west... There are more gateways. So every cluster has a north-south gateway, but also a east-west gateway. And so that traffic flows through these east-west gateways, which can be also private IPs, just the cluster has to be
essentially what happens, my front end, the sidecar, is what we call SNI header, right? The Envoy knows an SNI header, which is essentially an entry that tells the application how to go to the next hop, right? Which is the next level. So essentially, my front end knows that to reach the back end, it first needs to connect to the east-west gateway. The east-west gateway now knows to reach that back end, it needs to go to the end application. This is how we route that application traffic to the other version. Yeah.
And so this is what happens really, right? So developer push or open a pull request. I know the GitOps is we're always talking about pull requests in this case because we are a time constraint. We just push code. We should not do it.
I push things to main. We'd never do that, right?
Don't do that. But imagine this is somebody approving a pull request that merges into main. It's exactly the same thing. So there's a GitHub action that gets triggered, builds a new Docker image, push to Docker Hub with a new tag, and then the second part of the same action or another action,
I'll show the action in a second.
updates the tag in Git, and then Argo CD, the server running in Acuity, is constantly monitoring the Git repository, picks up the new tag, and then it says, there is something different here. So I'm running version X-1, and you just push version X. So I think I should update the deployment with the new version. So this is what we have to do, because of course, like it takes some time in the but it's done.
It's releasing the application. So luckily you spoke just enough time, because that last step is just a few seconds. So right now I'm released that application to Git to Docker Hub. If I go to Docker Hub here and I refresh my page, you'll see there's a new version that's just been pushed to my new version, and I should see last pushed a few seconds ago. I should zoom in. You see, this is the image I just created. That's that new version I just created. And right now, I'm telling Argo, please deploy that new version and create a canary release. Just to repeat, canary release, I'm going to send part of the traffic to the new version. In my example, so we can easily see the difference, I'm sending 50% of the traffic to the new version, because it's just easier to show. And if all goes well, pray to the demo gods.
You probably want to do like 10% or 5%.
Yeah, of
so
course.
You don't want half of your customers to see your new stuff.
You see, watch the front end here. It goes to canary now, and 50% of the traffic goes to front end, and the other 50% goes to my canary release. Right? And just to repeat, the only thing I did is I pushed code. That's all I did. So basically, who does what in this workflow? Whoever manages the application team, the platform team, sorry, the application team or the platform team has decided when there's a new version, we'll do a canary release. You can also do things like dark launches or blue-green deployments and things like that. Let me quickly show you the object that I used to create that canary release, so you understand. I mean, it's an object that we provide from the Glue platform. In the backend, we actually translate that to a bunch of Istio objects. We make the consumptions of Istio actually way easier thanks to some of the objects that we have. So let me show you quickly what this looks like. Here you go. Up, I'm going to go to my fake service. It's called the fake service. It's written by an ex-colleague from HashiCorp called Nicholas Jackson. It's a really cool service to test applications with. So basically what I'm doing here, my route table front end, right? It's a route table. Essentially, whoever is familiar with Istio, this gets translated to a bunch of virtual services and service entries to kind of manage the traffic. And all I'm saying is when you reach the front end, right, send 50% of the traffic to the stable version. I'm tagging my deployments in Kubernetes. So there's on the front end, just quickly, there is a version label, right? So essentially, in my route table, I'm telling send 50% of my traffic to that version, and send the other 50% to my canary. As I mentioned, in production, or as Alessandro was mentioning, in production, you don't want to do 50%, you want to do something less. But this is so it shows up quicker. So essentially, what I can do now, I use customize. In GitHub, essentially, customize can be used to make adjustments to existing Kubernetes objects. I'm gonna know I need to do a git pull, because just to show you my workflow, right, actually updated that file, right? So if I do a git pull, you see it actually changed that file. I just downloaded the last version from my GitHub repo, and my process automatically changed that file and did that for me. So now I'm happy with my canary version. I'm going to do this 0-100. I'm going to change 100% of my canary version. I want to change the label to be stable, and I want to get rid of my old versions. But essentially, I'm going to send now 100% of my traffic to my. Okay, I'm going to keep the same up. And within a few seconds, I'm going to go and speed that up. I got a workflow in the backend that picks it up and pushes it to Argo. Sorry, it tells Argo to synchronize. You don't have to do that because Argo automatically synchronizes, but if I do that, it's just quicker. So it's just the only reason I do that is just for demo purposes, so the difference shows up quicker. If I go here, I'm going to see 100% of my traffic now, 100% goes to Canary now. You see, it's not going to front-end version 1 anymore. So this is super cool. And then Within Argo, there's another concept that can automate the whole release, so it can change the weight gradually. It's called Argo rollouts, right? With Argo rollouts, you can actually instruct to change the release, and you can actually do that based on metrics. So you can check metrics, and you can make sure that every time you go up, there's not too many errors being generated and things like that. I did it manually, but in this case, it works like that.
Okay.
Cool.
Okay.
The second demo.
Moving on.
Yep, moving on. The second demo, it's also pretty cool. So securing your workloads. I'm going to use Vault here, okay?
Right. So let me introduce the idea of zero trust security, why we want to do this, right? So we really hate when you have to embed a password, a secret. In Git is of course, the ultimate sin, but even just letting secrets be inserted as a Kubernetes secrets, which are not really secret, they're just basics for encoded.
It's just hashed.
That's bad,
actually,
right? So
yeah.
we want to move from these perimeter security ideas where when you are in, you're golden. You are a trusted person, and if you are out, you are just a bad guy. But no, we want to move on from this old idea of perimeter security into the new world of zero trust security, where even if an attacker can access credentials, can extract credentials from a user, and especially bad if he's a privileged user, that credential won't let, like in this case of perimeter security, won't let an attacker in. Will let the attacker in, but the attacker will have only limited window to.
So the way I tell my customers, I say, I can't design a system that nobody can get in. I think nobody can. You have to assume somebody will get in at some point. What we need to do is once they get in, to just limit any lateral movements, right?
Yeah.
And this is what we do with the mesh and with.
And with microservices, this problem is, of course, amplified. There's more to protect. You don't know what the services are talking to each other, if they are, and what they're doing. So they just more attack surface to protect. And that's why smart people like the NIST, the National Institute of Standards, introduced this idea of zero trust, which really is a set of principles, right? So like we just said, assume breach. Don't always verify, and don't assume. Don't let these passwords, these credentials, to be too long around, and just keep rotating them. So the idea is that service mesh. That's why the whole point of having why we are so adamant, so pushy about using service mesh for security is because service mesh, by embedding a proxy into every application pod, very close to the application, that is called in Zero Trust is called the policy enforcement point, PAP. So you can enforce policies because you are so close to the application.
I just want to add one more thing. We talked about sidecar a lot. Every time you add an extra thing to a workload, it's heavy on your infrastructure, right? I mentioned earlier on, we do have a sidecar less model. It's going to be officially, it's open source. It's going to be production ready after summer, I think, somewhere, where we can achieve all of the same things, but without sidecars everywhere, right? So people say, oh, I don't want a sidecar to be injected. I don't want that extra workload to be injected into every single pod. So it's going to be history very, very soon. If you want more information, I'm happy to talk to you about it after the session. But it's a model that we are working towards too, and it is actually working today.
Yeah. So, and there's also things like mutual TLS. They just become easier when you use a service mesh. It's not impossible to do it without. Just for us, it's just a thing that makes so much sense. So about this demo. Of course, like one of the principles is to use least privileged access. So we want to show that using Vault, you can first of all forget about passwords, or passwords are replaced by this ephemeral, transient credential. They are created on demand, on the fly, passed to the application, and then eventually rotated very quickly.
So one thing I didn't mention earlier. I use Vault here also for the certificates, for the encryption, for the mutual TLS. It's embedded in. I'm not trusting a self-signed PKI on my cluster, because very often that means I need to store my certificate and the key on the cluster, which doesn't make me very happy. So I use Vault here as well, which It was part of the demo, but it's part of the environment. And I'm going to make sure there is a repo. I'm going to make it public. If you want to see how this is all built, I'm going to make it public.
So quickly, what is going on? The application will need some credentials for a Postgres database, right? So there's a Postgres, there's a database. The application needs to have access to that to start up. Then there's an init container, which is it's quite similar to the sidecar model. Just a container that comes up before the application to do things. In this case, things is requesting a credential from Vault server. First thing it does is to send a request using the service account of the application itself. So the init container identifies itself against the Vault server with its own Kubernetes service account. So it's not some anonymous request, it's authenticated and is passed to the
So for
Vault
understand
server.
Kubernetes here, the way it works, Vault has the the token for that service account stored in its Vault. So whenever another service account, and it has also the Joe token to talk to the API. So essentially, when the pod connects to Vault, it authenticates with its own service account, and Vault can actually verify that service account and attach him to a certain role within Vault and give him credentials, essentially.
Yeah. So the Vault server has the ability to create these roles and these ephemeral passwords for the cloud native Postgres. So it's a Postgres database running in Kubernetes as well. Retrieves those and sends them back to the application.
Exactly.
And then the application is happy. They are stored as volumes, and then this volume is shared between the init container, the Vault injector, and the application itself. So at that point, the application should be happy enough to start up and start getting data out of the database. But those credentials will expire, and we have only 2 minutes expiration.
It's a
right?
2-minute expiration that we put, just as an example.
So every 2 minutes, the whole shebang, the whole dance starts again, and then there's because that's what it means to have ephemeral.
And to not have we wait 2 minutes, what I'm going to do is I'm going to show you that every time I restart the pod, there is a new set of credentials being injected, right?
Okay, got 8 minutes.
Yeah, it's enough, just enough. So this is unavailable because I'm going to deploy my front end. I got a Postgres database deployed. I'm going to start a front end, and I'm not going to put any credentials anywhere. I'm going to have, and I'll show you the way this looks like. I call it a payment service, right? Okay, is this very, no, I need to make it bigger maybe. Here you go. So I got a payment service, and I'm going to talk the payment app, and here the payment app, and I'm going to zoom in. What it does, it will do a few things. It will inject into the pod, and I can specify a template for my connection string, because every language has another way of consuming connection string. .NET Core is a certain way where you have to do the application settings so you can have it environment variables. Spring Boot does it a certain way. So I can tell the Vault injector to generate the connection string or generate the connections in the way I want, and it's going to replace this with placeholders, right? It's going to replace the placeholders are going to replace this with the passwords or the authentication from the from Vault. And the same thing here with the database. This is because I got a payment processor which needs authentication. This is a static password that I've stored in Vault that I'm going to inject here. And the magic happens here for Postgres. I'm going to tell the Vault to generate a dynamic token and to inject that into the application. Now, as a developer, all these labels, all the annotations that you see here can be automatically injected by your pipeline. So don't worry about it. You can just say, you developer, just deploy your application. I'm going to inject these things into your application, and it's going to automatically generate it behind the scenes. So I'm going to now deploy and I'm going to just deploy my payments app. So this is essentially my front end, right? And I'm going to deploy it into my cluster. Here you go. Deploy front end. We're going to push it. Again, I'm doing it to main. We don't do that, right? So I'm going to go here and just, this is Argo, right? I'm going to go to my payment cluster 1, and I'm just going to accelerate the synchronization. It happens automatically normally, right? But I wanted this to happen a bit quicker. So this should be deployed now. I'm going to refresh this page. It's going to take a few. Here you go. So my application, this is data that comes out of the database. You'll have to believe me, this comes out of the database, right? Well, I'll show you. So essentially, this is just 2 items. I got some red panda and a red panda 2 in the database that has been deployed. I got the same on cluster 2. So cluster 2 has been deployed, but cluster 2 doesn't have the database. The database only runs on cluster 1, and I'll show it to you so you make sure you believe me. So if I go to my payments, my payments namespace, here you go, my payment namespace, I've not deployed the other one yet, my bad. So this is why this is not running. So I need to go to cluster 2 here and accelerate the deployment. There you go, refresh. There you go, and it's going to deploy it as we speak. So I should have, here you go. So you see the payments app runs here. And essentially, if I go here again, I should have a application 2 connecting to my database as well. And if I go to my same namespace in cluster 1, I'll see that this is where my database is running, right? So you see my payment database runs here. What I'm going to do is I'm going to delete this. Oh, I'm going to first execute into this part, and I'm going to show you, right? Oh, not good. I'm going to show you the credentials that has been injected. I'm going to remember some letters to make sure that next time I show this to you, you see it's different, right? So if I do a slash here, it's stored as a secrets, and I'm going to database properties. So remember the last numbers of the password, for example, username, right? Just keep it in your mind. I'll try to remember it as well. I'm going to restart the part, and you're going to see there's another set of credentials that are going to be injected here. So I'm going to delete this one, and automatically a new one is created. This is Kubernetes doing the deployment for you, because I got a deployment that says I always need at least one version of that app running, and essentially Kubernetes is doing this for me. I'm going to execute into the pod again. Remember the password from before? I didn't, at least. Vaults, and then up secrets, and then database properties. Is it different? Yeah, different? Cool. So this is all Vault magic behind the scenes, right? So this is pretty much it from a demo perspective, because we've got just 3 minutes left, and there's some beer and everything.
Yeah, beers, yeah. So very quickly, we just want to...
Oh.
So we wrap up. We learn we hope you learn quite a bunch of things, like how to glue these things together, Argo CD, Istio, multi-cluster, Vault, and all in Kubernetes sauce. So we want to tell you that all this and other things and a lot of more learning is available on academy.solo.io. Some of the courses are written by Jona, by me, so it's a place to learn.
And so then you get a little certificates on Credly you can post on LinkedIn and be cool, right?
Yeah.
So we have official Istio certificates, right? So if you want to sound cool in the community, just go and do the exams. It's super easy.
Yeah. Never stop learning like we do. I mean, it's and we would like to thank you. And there's a link to the slides if you need, or just contact us, and we'll be happy to provide. So, any questions? We got a bunch of minutes before the beer, so
take a picture. Can I be on a picture? No? Okay.
Don't be shy. Or
I hope you enjoyed it at least. I hope this was interesting. I hope you learned something today.
Cool. That's a good day then.
That's a good day. Just put a lot of green cards in the bowl when you get out, right?
All right, cool.
Thank you.
Thank you.
Right.